सो हेलो नमस्कार टू द ऑल केमिस्ट्री लवर्स। मैं विजय कुमार सोनी आपका स्वागत करता हूं केमिस्ट्री वाला चैनल पर रिगार्डिंग टू केमिस्ट्री। In previous video we have discussed about a lot of things regarding to just coordination compound or just you can say complex salt. Today we'll go with the just importance of coordination chemistry or coordination compounds. Means coordination compound हमारी लाइफ में हमारे लिए कितने important है, क्यों important है, उन सब की बातें करनी है. So these are the applications of coordination compounds. If we'll go with the first application, then we can say coordination compounds are too important for the human body in many of field. These are as following. First is your in biological system. This is the in biological system. If we'll go in the biological system, then one of the important compound that is called as chlorophyll. It's a complex compound of, you can say, chlorophyll is the complex compound. It's a pigment. It's a pigment, green pigment, and it is helpful in the. It acts as a photosensitizer in photochemical reaction. In photochemical या photosynthesis reaction. How? And it is complex compound of magnesium. So we can say that it's too important for us. B is your, we can take just important, that is your hemoglobin. This is the hemoglobin. It's a O2 transporter in human body. Just it's a red pigment of blood. Red pigment of blood is a complex compound of iron. So we can say that it's too important for us. Now the time to discuss about the third application, that is the vitamin B12. Vitamin B12, its another name is cyanocobalamin. It is complex compound just cobalt, and it is pernicious anemic factor. This is the anemic factor. So this was about the three important applications in biological system. Now I would like to go with the third application in the biological system, that is the fourth important application in biological system. What is that? Carboxypeptidase. This is the carboxypeptidase. Peptidase is a complex compound of is a complex compound of Zn, zinc. It is used as catalyst, or you can say as enzymes in our bodies. Enzymes in our body. Now the time to discuss about the second application. What is that? As you can say catalyst. As catalyst, if we go with the important catalyst, that is the Wilkinson catalyst. Wilkinson catalyst. The structure of Wilkinson catalyst is your RHCl. This is the pH whole thrice P whole 3. It is also called as chlorido tris triphenyl phosphine, just rhodium first. It is used in selective just reduction of alkene, means particular how we can get just cis and trans isomer from the alkyne to alkene, and just alkene से particular आपको रेजियो सेलेक्टिव मिक्सचर बनाना है, then it will be use of Wilkinson catalyst. Read the entire matter properly because it's too important. Wilkinson catalyst. Now the time to discuss about the second application of coordination compound. Third application of the coordination compound. First we have discussed as a biological system. Second we have discussed about as a catalyst. Now the time to discuss about the third application. This is the third application in purification of metals. Metals, you can say just like nickel, can be pure by using the formation of complex compound, or just you can say by using coordination chemistry. So this is the impure sample of nickel. This is the impure. First of all, we'll treat it with the carbon monoxide. So it will formation of a complex compound NiCOs whole 4, and on further at the high temperature, this is called as tetracarbonyl nickel 0, and we have discussed in previous video all the carbonyls exist 0 as oxidation state. On further heating at high temperature, it will separation of Ni and 4 of CO. Now this Ni will be as a pure Ni, and this technique is also called as, entire method is called as Mons process. This is the Mons process. This is the Mons process, entire method of the purification of the nickel. If we'll go with the just with the another technique, another application, then that is your in extraction of metals. In extraction of metals, for the extraction of AG and AU from their ores, we can use this method, means formation of complex compound method, and that method, the name of that method is called as cyanide process also. It is also called as leaching of ores, leaching of ores. Along this, suppose we are taking here just silver sulfide as a ore, then it will use of sodium cyanide as a solvent. So it will change in, this is the Na, Ag, Cn whole 2, and now here is the Na2S. On addition of more reactive metal in it, in the solution of sodium dicyanide अर्जेंटेट फर्स्ट, इसमें आपने पर्टिकुलर ऐड किया इससे मोर रिएक्टिव मेटल लाइक यू कैन से जिंक. सो दीज टू मॉलिक्यूल AgCN whole 2 reacts with Zn to give, this is the Na2 Zn Cn whole 4, and it will be removal of precipitation of 2 of Ag. Here will formation of sodium tetracyanide zincate second. So this was about the just third application in purification of metals and just in extraction of metals. Now the time to discuss about the fifth applications of the coordination chemistry. This is fifth application, that is your, you can say, in the removal of hardness of water. For the removal of hardness of water, it will use of by using EDTA, means ethylene diamine triacetate or tetracetate. By using EDTA, we can remove hardness of water, as you can say Mg plus 2 and Ca plus 2 ion, where Mg will remove in the form of Mg. This is the EDTA, Mg2 EDTA, and calcium will be removed in the form of Ca2 EDTA as a precipitate. And EDTA is also used in complexometric titration also. Now I would like to go as medicine, means as medical field, as in medical field, complex compound are also important. If we'll go with the first, then cisplatin means cis form of PT. This is the NS3, yeah, you can say Cl2 NS3 whole 2, or you can say NS3 whole 2, both are right. NS3 whole 2 Cl2 is used as you can say anti-tumor or anti-cancer ड्रग कैंसर को ट्रीट करने में इसका यूज करते हैं. नेक्स्ट इज योर टॉक्सिसिटी of lead in our body can be removed by injecting EDTA. मीन्स अगर किसी बॉडी में, ह्यूमन बॉडी में लेड की इम्प्योरिटी आ गई है तो उसको रिमूव करने के लिए EDTA का यूज करते हैं, जो कि पर्टिकुलर उसके साथ ट्रीट करके, रिएक्ट करके, और इन द फॉर्मेशन ऑफ द सॉल्युबल सॉल्ट, कॉम्प्लेक्स सॉल्ट की फॉर्म में यूरिन से या स्टूल से एक्सक्रीट कर दिए जाते हैं. Now I would like to go with the third application regarding to in medicine. What are they? This is the you can say BAL. This is the third application as medicine. BAL. The full form is your British anti-leucite. British anti-leucite is used to remove toxic metals such as Hg, AU, CD, PB, etc. British anti-leucite. It's very important, BAL, because it forms antibody whenever it enters in our body. जब हमारी बॉडी में एंटर करता है तो पर्टिकुलर ये हमारी बॉडी में एंटीबॉडी को क्रिएट करता है. एंड इफ वी वांट टू रिमूव for the removal of excess of Cu, it will use of penicillamine and excess of iron can be removed by using desferrioxime B. इनके थ्रू आप पर्टिकुलर टॉक्सिसिटी को रिमूव कर सकते हैं. Now the seventh application in photography. What is that? Seventh application is your in photography. You all know पर्टिकुलर पुराने टाइम पे जब भी फोटो खींचते थे तो कैमरे में एक रील लगती थी, उस रील पर एजीबीआर सब्सटेंस होता था। जैसे हम फोटो क्लिक करते थे तो लाइट के कारण एजीबीआर फोटो सेंसिटिव होता है, और फोटो सेंसिटिव होने के कारण पर्टिकुलर इसका डिकम्पोजिशन होता था लाइट की प्रेजेंस में। देन इट डिसोसिएट इन एजी प्लस एंड बी आर माइनस। फोटो सेंसिटिव, लाइट सेंसिटिव, फोटो सेंसिटिव substance है। This AgBr further, Ag plus further by the reduction changes in Ag and it gives the black color। ये black color देता है बेटा जी। अब जैसे आपने फोटो क्लिक की तो लाइट आई तो उस डायग्राम के सराउंडिंग का पूरा पार्ट ब्लैक हो जाता है। उसको डेवलपिंग के लिए हाइपो सॉल्यूशन का यूज करते हैं। सो फॉर द formation of permanent film, it will use of hypo solution as developer hypo solution is your Na2S2O3. This is also called as sodium thiosulfate. Now what will be? This is the AgBr. We can take two molecules. This is the Na2S2O3. We can take two molecules. 2 of Na reacts with the 2 of Br. This is the 2 of NaBr, and rest it will formation of Na2 AgS2. Yeah, you can say this is the Na S2O3 whole 2. This is the NaAgS2O3 whole 2. This is the plus 2 of NaBr, and this is the 2 molecule. Here with formation of sodium dithiosulfato argentate first as a complex compound, which gives the permanency to the film. Here we can use just one of the mistake is AgBr, and just here is the Na3, because oxidation number is not balanced. 2 to the 4 and plus 1. This is the plus and this is the Na plus. So this was about the just sodium dithiosulfato argentate first. Now the eighth application of the coordination chemistry. What is that? I am erasing one by one, so it will be convenient to read the matter for you. This is the 8. As dyes, many of substance, you can say Fe4 FeCN whole 6 3 minus. It is called as Prussian blue. It is blue color dye. It's a complex of iron which is used as dyes. If we'll go with the further, then we can take, that is the qualitative analysis. analysis. Qualitative analysis is also called as radical analysis. Radical analysis. During the radical analysis, specific, basic, radical analysis, it will use of it will use of you can say just coordination compound या coordination chemistry, coordination compound or complex compound, complex compound. How? We'll see the matter. So regarding to ninth application, first of all we'll go with the detection of Ni and Cu. So regarding to ninth application, what is that? First is your for the detection of Ni plus 2, it will use of DMG, means dimethyl glyoxime. It can be written as follows with NH4OH solution. Listen me carefully. This is the NiCl2 in the form of Ni plus 2. This is the 2 of NH4OH. This is the 2 of CH3 double bond and OH, double bond and OH. This is the dimethyl glyoxime. It's not a glyoxymato तो अब बनेगा. This is the DMG, dimethyl glyoxime. So whenever these reacts with each other, then simplest compound it will formation of Ni. This is the DMG whole 2. It is called as bis dimethyl glyoxymato nickel second, and rest it will removal of you can say 2 of NH4Cl and 2 of S2. If we'll go with the structure, then this is the Ni, this is the you can say NOH, this is the NOHC, here is the double bond, this is the CS3, this is the C, this is your CS3, here is your N, this is the coordinate bond O, here will donation by as follows, and another will be as follows CS3, this is the C, this is the C CS3 double bond N, this is the O coordinate bond, here will single bond, and this is the double bond OH. So NOH. So the donation will be as follows from here. So this is the structure of bis dimethyl glyoxymato. This is the bis dimethyl glyoxymato nickel second. Now the time to discuss about the second application as a qualitative analysis. What is that? That is your second for the detection of Cu plus 2. It will use of K4 Fe CN6 potassium ferrocyanide. So this is the CuSO4 plus this is the K4 Fe CN6. This is the 2 of molecule. It will removal of, you can say, K2SO4, 2 molecule. Potassium is balanced and rest is your Cu2 Fe Cn whole 6. Here will formation of chocolatey brown PPT, and for the detection of Fe plus 3, it can be used of again K4 Fe CN6. How? This is the, suppose FeCl3. This is your K4 FeCN6. Here will take just 4. Here will take 3 molecule. So it will removal of, you can say, 3 4 the 12 of KCl, and rest it will formation of Fe4 Fe Cn whole 6 whole 3. It is also called as Prussian blue. Here will formation of a dye. It is also called as ferric third hexa cyanidoferrate second as a complex compound. So this was about the just important part of the application of the coordination compound. Now the time to discuss about a very short topic, that is the Sedgwick theory, and it is also called as effective atomic number. What is that? Listen me carefully. This is the Sedgwick theory, or you can say effective atomic number. By using this number or theory, we can calculate about the stability of just complex compound. If the complex compound, its effective atomic number is equal to the nearest inert gas, then that will be as a stable complex compound. मीन्स अगर किसी भी कॉम्प्लेक्स कंपाउंड की इफेक्टिव एटॉमिक नंबर उसके नियर इनर गैस के इक्वल हो तो उस पोजीशन में वो अपने आप में कॉम्प्लेक्स कंपाउंड स्टेबल होगा. फॉर एग्जांपल, इफ विल गो विद दिस इज द एग्जांपल, वी कैन टेक CO, दिस इज द NH3 whole 6, this is the 2 plus, or we can take, it's a very important example. What is that? This is the FeCN whole 6 4 minus. The formula of EAN is your atomic number minus oxidation state plus total number of donate electrons. So if we go with the FeCN whole 6 4 minus, then the oxidation state of Fe is your plus 2 6 minus 4. So atomic number iron, it will be just 26. Oxidation number is your 2. Here is the donor electron is your 6. एट अ मोमेंट एक लॉन पे डोनेट किया तो 6 2 12 इलेक्ट्रॉन हो गया आपके पास में. So it will be 24 and plus 12. This is the 36 and it is equal with the krypton. So this will as a stable compound, and this was about the effective atomic number. If it is not clear by you, then you can take another example also. This is the second example. CONS3 whole 6, this is the plus 3. Then the atomic number of the cobalt from the formula. This is the effective atomic number. This is the important formula for the calculation of effective atomic number. So regarding to it, first of all, oxidation state will be plus 3. Atomic number for the cobalt is 27 minus 3, and donate total number of the donor electron is your 6 to the 12. So it will be again your 24 plus 12, it will be your 36 equal with the krypton. So both are the stable complex compound, but effective atomic number is not applicable. Effective atomic number is not applicable for metal carbonyls, So this was about the effective atomic number or Sidgwick theory. So in this way we have discussed and completed the whole entire chapter as a coordination chemistry. We'll meet in the next video with the just practice of the questions and further chapter also. Till then, shukriya, dhanyawad, thank you.